Welcome back, guys. Just a little reminder as to what we're going to be coding over the next couple of videos. I'll finish this up here. And we're going to get back into this today, and we're going to be in background, and then we're going to look at some of the more asteroids and things like that as well. So let's get into it right now. Okay, so I have up here the code that we started last lesson, or last session rather, and what we're going to do now, so we have an enemy class and we have a player class, is we're going to create a background class. So this is a scrolling class. It's actually quite nice because we can use this for a range of different games. And the idea of this is that we're going to load in a background, and then above that background off screen we're going to basically load it again. So we have these two backgrounds, and then as the one that's on screen moves down, the one that's off screen moves down as well at the exact same speed, so that as that one is moving down the screen, the one which is above the screen is coming onto the screen, and then we can get that kind of rotation from there. So we're going to go through actually how to do that today. So we're going to create a new class here called background, and we're going to do our def init self as well from here, and then we're going to initialize what we need, so our attributes from here. So we want a background image, and that is going to equal Pygame image load, and then we give the image. So in here I've actually got a couple of different images now, so let's try background image 2. .png is the one I'm going to go for. So I'll drop all of these into the GitHub as well, so you can mess around with different background images. So we've got that background image there that we're going to load in. Now we need to create a rectangle for that, because it's going to be the rectangle we kind of move. So the rectangle of the BG image is going to be equal to self.background image dot get underscore rect. Okay, so we're saying get a rectangle of this image size, so the one we've set here. Now let's set our rectangle up, and that's it really. So the next thing we need to do is we need to set an x and y coordinate for a starting point for both the images. So the image which is going to start on screen, the starting point for it is top left corner is going to be 0, 0. So if we set self.background y1, that first is going to be 0. And then we're going to set its x to exactly the same. So self.background x1 is also going to be 0. Okay, so that first image, when we load this first image in, it's going to actually start at 0, 0. So we want the second image to start basically right up, sort of up out of the screen, and the bottom of it will have to be down here, so they meet neatly. So the way we're going to do that is we're going to say self.bgy2 is going to be equal to negative self.rect bg image dot height. Okay, so what this will do is this bg, this here will have a height to it, and this here, so if the height is 600, this will be minus 600. So this will set that y to minus 600, so that's all the way up the top out of the screen here. And then its x can be set to 0 because we want it to be on the same x-axis from here. So self.bgx2 is going to be set to 0. Okay, so they're all exactly the same. So they're going to be in line with each other, but this second image, when we actually make it, will be on top of the first image at exactly that image's height. You'll see how it works in a second when we actually get it working. Next thing we need to do is actually have a move speed for it. So however fast you want your background to be running, that's the number you're going to put in here. Okay, so that is our attributes for our backgrounds. We are now going to just create a function to get the whole thing moving. So def, and we're going to update. So this is going to be what updates the actual x and y coordinates. So basically we want to update these by the move speed every single frame. So we're going to increment them. So self dot, so it's the y that we want to increment. Y1 is going to equal itself plus the move speed, and this will happen every single frame. And we're going to do that again for y2. So this means that the y-axis are going to be updated by that move speed. So if we think about y1 is set to 0, so every frame we're going to add 5 to it. So 0 is at the top, 5 is a little bit further down, so it's going to go 5, then it's going to go 10, 15, so it's going to go down and down and down and down and down. And then if you think about our y2 is set to minus 600, so that's right at the top. So every frame, that's going to be minus 600, then it's going to be minus 595, then it's going to be minus 590, minus 585. It's going to keep on, so that's going to why it's going to be coming down. Okay, so that's how those two work together. So once my image goes all the way off the bottom of the screen, I want it to reset back to the top of the screen. So I'm going to check that y coordinate again for both of them. So if self.bg y1 is actually greater than the rectangle's height, so self.rect bg image dot height, then what we do is we just reset it to its starting point. So we reset it to the negative version of the height. So if this y, so as it's incrementing all the way down the page, so it goes y1, it keeps going, it goes going. So if my image is set to 600, if this ever becomes greater than 600, I'm going to reset the y so it goes up to the top, so it goes to minus 600. So it loops around, so it goes all the way up to the top. So that replaces that image at the top of the screen, ready to scroll down again. And then the same, I need to do exactly the same for the y2. So they are exactly the same for the y2 there as well. And that is my update loop done. So my y attributes are the only ones that's going to update. I'm going to update them by move speed, and if the height, if the y1 is ever greater than the rectangle's height, I am going to reset it so it goes up above the screen so we can't see it, and then it will slowly come down the screen. Okay. So the next thing here is actually my render loop. So def render and where it's going to render it to. Actually, no, I don't need to do that just yet. So just self in there. And then all I do is window.blit and self. Just make sure that it is window that I'm using. Yeah, it is window. So window.blit, and it's going to be self.background image, and then I give it the coordinates. Okay, so it's going to be self.bgx1 as the first coordinate, and then self.bgy1 as the second coordinate. Background image, yeah, that looks good to me. And then the same for the second. So that draws the first image to the screen, and then I do exactly the same again, but just passing in the second set of coordinates, x2 and y2, to draw the second image to the screen. Okay, and then these two will be moved by my update function. And that is more or less it for the whole background. So using this now, you can mess around with the X and Y's and stuff like that and make a left and right scrolling. They are pretty, it doesn't need much at all to change in order for it to actually be able to work on a number of different games. So what do I need to do now? I need to actually create a background. So background equals background, like this. So now that I've got my background object created, I'm going to go down to my while loop and I'm going to update that. Now there's one thing we need to make sure we do with this. At the moment, my update loop is continually filling the window with black. But obviously, if we're drawing an image onto it, we don't want to fill it with black on top of the image because we're not going to see the image we're drawing to it. So now we're going to get rid of that line. And in the while loop here, we are going to do background dot update. So I'm going to update its position, and then we're going to do background dot render to draw it from here. So with that all said and done, that should now work. So let's press F5 and see if it works. Didn't like it. Move speed is not defined. So let's have a look here. What have I done? Oh. So I needed to do self.move speed for these two here. So self.move speed. Obviously, because I need to say that I'm updating this move speed here. So let's try that again. There we go. So we've got our rolling background now, and that looks pretty good. Okay, and we can change that, and there's a number, whatever. Just swap that image out, and they are the same width as the canvas that you're using. So you can check that at the top of our code. It shouldn't have any problem scrolling through them. So what we're doing now is we want to actually look at adding in some collisions. So to add in the collisions, we've already got an enemy 1 here. So let's actually make this a bit more difficult, and we're going to add in an enemy 2. That's going to equal enemy, and then we're going to update the enemy2.move, and we're going to update the enemy2.draw as well. Okay, and we obviously need to draw it to the window. So we are actually going to automate a lot of this, so we have to keep. So if we had 5 enemies, you wouldn't have 5 move functions and 5 draw functions. We're going to automate a little bit of that, but we're going to keep it simple for the time being. So what I want to do, first of all, is my enemies, I'm going to place them all into a group. And what I want to do is I want to know if the coordinates of any of these enemies ever intersect with the coordinates of my player. If that actually turns out to be true, then I will end the game. So in order to do this, I'm going to use a group. So if I enemy group equals, and I do Pygame.sprite.group with capital G like that, because it's a class, I can now add in my 2 enemies. So I do enemy group dot add, and I add in my first enemy. I do exactly the same for my second enemy. So now what I can do, and I'll be able to use this same enemy group to do all my move update functions as well automatically in a minute. But what I can do with this is I can actually check if this player ever collides with anything in this group, then it's game over basically. In my while loop here, I need to add a condition for that. So I'm going to do if, and I'm going to use the inbuilt collision detection. So if Pygame.sprite collide any, and then I give it the 2 arguments. So if player 1 ever collides with enemy group, we're going to end the game. We are going to window.fill, and we'll fill it with black, and we will update the display with that black .display.update, and then just for time being we are going to do we're going to quit. So with that said, now I should have 2 enemies and a scrolling background, and if I collide with my enemy, so I've got my 2 enemies there, nice and easy. So let's test that collision. So there we go, black. So that's good, that's working as it should do. What we want to do now really is we actually want to have a look at updating this loop here. So we have like a pause, and then we have some text come up or something like that. So first things first, we need to make sure we've imported time. So up here with our imports, I'm also going to do comma, I'm going to import time as well. And back down to here. So once I've updated the display, I want to just time.sleep. I want to wait for a second or a couple of seconds here before I actually end the game. So this will wait for 2 seconds before ending the game. So what would be good to actually have here, we need a couple of things. So we're going to add in obviously like a game over font or something like that as well. So we need to go back up to our imports, and we're also going to import SYS. So this is going to import system. It's going to let us create fonts and things like that. Now I'm going to do this just on top of my while loop so we can see how it's working. So what I need to do is I need to load a font for my system to actually use. So I'm going to do font equals pygame.font.sysfont, and then I give it a font to load, so something like Verdana, and then I give it a size. So 60 is absolutely fine. So this loads in this font at this height, at this size. So what I can do with this now is I can actually create a piece of text with this font. So in order to do that, I need to create a variable to hold it. So game over is fine, and it's going to be the font I've just created dot render, and then I tell it what I want it to say. So I want it to say game over, and then I write true, and then I give it a color as well. So at the moment I only have, I think I have black. I only have black drawn, so I'm just going to give it black, and then I'm going to close it out from there. However, at the moment I've also filling my window with black, so we're not going to see that when we get our game over. So we're going to change one of these colors. At the top here, where I've got my black, I'm also now going to do red, which is equal to 255, 0, and 0. So if I scroll back down now to my while loop, this now, instead of filling that with black, we're going to fill that with red. Now, once I've filled the display with red in there, what I want to do is I want to actually display that, that game over. So what I do is after I've filled it with red, I'm going to do window.blit, and I'm going to pass it the variable name here, game over, because that contains the text that I want to display. And then I'm going to give it a position. So just to test it out for a second, 100 by 100, although what is our, so it's 500 by 600, so 250 by 300 should be a good position. So let's put it in there, 250 by 300, might not be quite in the middle, but we'll have a look at it. So taking its time to load. There we go, in the near collision. So we've got a game over, but it's happening. One of the things we could do, we can make the font a little bit smaller, so maybe having the font at about 40 instead. And we could change, maybe change this to just 50. Let's see how that looks. Okay, so that's over on the left hand side. So those numbers here, so maybe it would be more like 100 or something like that, and that would get it more in the middle. Okay, so there's our game over bit from there, and then it quits Python, and we move on from there. So we've got our updating players, we've got our sprite collisions from here. We're going to now just add in a score function. So the score function is pretty straightforward. We are going to set the score to 0 first of all. And what we want to do, actually, before we do that, we can still set the score to 0 there, but what is going to happen, our enemies are going to tell us whether or not we are scored. So if we look up here to our enemy function here, when they move, in this if function here, if they ever reach the bottom of the screen, that means we've avoided them. So if we avoid them, we want to actually increment our score by 1. So this is where that will happen. However, the problem with that is that because I've not updating all my enemies at one time here, the more enemies I have, the more convoluted this is going to get. So what we're going to do instead is, instead of having a separate e1.move and e2.draw and stuff like that, we're going to, in our while loop, we're going to actually use the enemy group, and we're going to draw all the enemies at once. So if we did it for enemy in enemy group, so for enemy in enemy group, what do we want to happen? We want to do enemy.move and then enemy.draw. So this will move and draw all of our enemies at once now. So I'm going to get rid of all of these, and what happens now is that I can actually create more enemies. So I can make another enemy here if I wanted to, add them into the group once they've been created. So I just add them into the group here once they've been created, and then they all move at once using just these 3 lines of code. So instead of just having to update them all the time. So if I run this now, we should, once it wakes up, we should see that that will be running. Or maybe it doesn't. Oh, sorry, so window.draw, I need to write window in here as well. So that's the argument it takes, hopefully, once it wakes up. So there we go. So now we've got our 3 enemies there, and with them. So we'll have a look at the collisions detection in more detail another time. So that's drawing all of our enemies from there. So with that as well, I said that we're going to actually be able to update the score from here as well. So if we have enemies, we'll actually, if we do it like this, score equals enemy.move and score. So enemy.move is going to take our score. And if our enemy is if we ever trigger that bit, which means they go all the way down to the bottom of the screen, we'll actually add 1 to our score. So if I just scroll up to my enemy class here, in my move here, I'm going to say it's going to take a score as an argument. And then here in my if statement, I'm going to increment score. So score equals itself plus 1. And at the end of every time I call move, I'm going to return score. Okay, so I return score. So if I ever increment score, it gets updated here, and I return that back to my main game. That gets saved here, and then I can use that score function to actually render some text in just a second. So at the top of my while loop here, actually we can actually set it here. No, we'll render it in the while loop. So what we want to happen is we want to, this sort of same thing here is what we want to do with the score, but because the score is going to update more or less every single while loop, we're going to render it within the while loop here. So we're going to do maybe something like score render, and it's going to equal the font we set up dot render, and then score like this. And then what we will need to do is we need to actually add, and we need to say we want the string version of the variable score, because score is actually a number. So we're going to say we want you to just write this out as words. That's what this bit here means. And then we're just going to say true, and we're going to give it a color as well. So black is absolutely fine for this for the time being. Actually, I'm going to make it red because that background might not show the black easily. So every single time we run this, obviously score is going to be increasing, and we're going to be updating this this actual rendered wording of score in here. Now also within here, once I've drawn the updated the background and all the rest of it, I want to actually draw the score onto the screen. So I'm going to do window.blitz, and I'm just going to say what do I want to score, what do I want to draw. So that's score render, and then where do I want to draw it? So let's draw it in the top left corner. So this now, if I run this, should draw the score in the top left corner for me. So there we go. So we've got my score drawing there in the top left corner. We saw that it did update. Run it again. So hopefully this lasts a little bit longer. So there we go. We've got my 3. We've got my 3 and then 6. And it's incrementing each time. Okay, so that's our score working as well. So the final there, as our asteroids were moving down the screen, they're always in exactly the same position when they move, because they all had the same starting position. If we scroll up to where those asteroids are actually, where they're actually made, this is the problem here. We actually give them a random position along the screen, but we always say they need to be set at the top of the screen. But if we change this, we can actually make it so they actually appear above the top of the screen and come down the screen. So we can do exactly, so this center point here, we can do exactly the same by doing random dot rand int, and in the brackets we give a negative number first, so minus 100 say, up to 0. So they can spawn off the screen up to 100 pixels above the screen and to 0. I'll just make sure I've got enough brackets here. 1, 2, 3. So it's 3 on the end. I need to use that same piece of code in here for this piece of move here. So I can grab it from there. And let me just check. So there we go, and then that's the 3 brackets on the end there. So with these two together, my asteroids should now spawn above the screen, and they shouldn't be all together in exactly the same spawn. So let's have a look at it, see if it loads. So there we go, you can see straight away that obviously I'm just going to comment this out because it's going to be a bit of a pain to test it otherwise. So I'm just commenting out the collisions just so I can test it for a second. So there we go. We can see there's a little bit more of a difference there. And obviously, the longer you play it, the further they're going to get away from each other. Or you could, so we can see there's a little bit further there as well. Or you could obviously set those two random integers to even further away from each other. So that is it for today. So next time we're going to be adding in the bullet and we're going to be tweaking a little bit more of the code. So I hope you guys had a lot of fun with that today, and join us next time for part 3, which is the final part of this code, and we're going to finish off all these last bits and pieces. So we'll see you next week.